Hi guys, I am Dr. Ganesh. In this series ml-demystified, I am trying to explain or share my knowledge on machine learning. We have seen basic steps in machine learning, the 5-step process. We have also seen one type of an algorithm called decision tree in detail. Decision tree is used for both classification and regression. In this session, we are going to see another widely used classification technique called nearest neighbors or K nearest neighbors to be precise. It's a supervised machine learning algorithm as target variable is known, and it is a non-parametric algorithm as it does not make any assumption about the underlying data distribution pattern. It is a lazy algorithm. Important point guys, as KNN does not have a training step. All data points will be used only at the time of prediction. With no training step, prediction step is costly. An eager learner algorithm eagerly learns during the training step. Now KNN is used for both classification and regression. How it classifies is by using feature similarity to predict the cluster that the new point will fall into. Assume you moved to a new neighborhood. Say you shifted your city from say Bangalore to Chennai. Now you want to have some friends with your neighbors. How do you do that? You start socializing, isn't it? You start smiling at some of the strangers, nearby strangers, tell them you are so and so coming from so and so place, listen to them, then slowly pick those neighbors who match your thinking, interests, and hobbies. Here, thinking, interest, and hobbies are features. And you decide your neighborhood friend circle based on interest, hobby, and thinking similarity. This is highly analogous to how KNN, K nearest neighbors algorithm works. So what is K? It's a point used to identify similar neighbors for the new data point. Referring to our example of friend circle, assume we select 3 neighbors that we want to be very close friends based on common thinking and hobbies. In this case, K is 3. So KNN takes K nearest neighbors to decide where the new data should belong to. For example, and what should be the value of K? It should be something optimal. If you just look at one person or two people next to you, maybe the decision is not very good. Maybe the third or fifth person is much better, has much better matching with your interest and thinking. But on the other side, you can't look for everyone from Chennai to make a decision. It's huge. So you have to find something that works better for you. We can take the test set and plot the accuracy rate or F1 score. I hope you remember what is F1 score. It's a score that gives you the both precision and recall values as a summary. So an example plot of K value versus F1 score gives you a good understanding of what is a good K value. And see that here K equal to 5 gives the best F1 score. The test set reaches a minimum error rate when K equal to 5. You also note that I have chosen only odd values of K in my calculation. Any idea why? While determining close match, even value may result in a tie, isn't it? Maybe two of them are at equidistant. And if two of them comes from two different categories, where will I fix myself? Whereas if it is 3, out of 3, 2 will from one category, 1 from another category, I will be able to fix among one. So how does KNN work? We have age and experience in an organization along with salaries. Assume that is an example. We want to predict the salary of a new candidate based on age and experience. Choose a value for K. K should be an odd number. Find the distance of the new point to each of the training data. Find the K nearest neighbors to the new data point. For classification, count number of data points in each category. Among the K neighbors, new data point will belong to the class that has the most neighbors. For regression, value of the new data point will be average of the K neighbors. So let's take an example. We have three classes already identified. A red diamond, yellow circle, and yellow triangle and green star. Now I got a new value, a blue dot circle, and this blue circle should be categorized among one of the three. Assume k equal to 5. That means from this blue circle find the 5 nearest neighbors. So when I found that 5 nearest neighbors, there are 3 red diamonds and 2 yellow triangles. So the highest one is from the red diamonds. So this blue circle will actually become a red diamond. Now the distance calculation is very important. So KNN captures the idea of similarity, sometimes called distance or proximity or closeness, with calculating the distance between points on a graph. And that essentially means you should know how to calculate distance. Some of the popular distance algorithms are Euclidean distance, Hamming distance, Manhattan distance, Minkowski distance, and there are many more, believe me guys. Whereas intuitively Euclidean means it's a distance between 2 points, whereas Manhattan is more like a city traffic. Manhattan reminds you of New York, right? So in a city traffic, you will go through squares, and finally reach the destination. Minkowski try to see it as a circle, and so on and so forth. So Euclidean, the straight line distance between two data points in a plane. You can calculate it by square root of sigma xi minus yi the whole square. Whereas Manhattan is a city traffic distance where I have to move in blocks. It's also called a city block distance or taxi cab geometry. So you calculate it by sigma I from 1 to n xi minus yi. So for example, given 2 points here, the Euclidean distance will be 5. It is essentially like a triangle formula, Pythagoras formula, and the Manhattan distance gives you 7. Minkowski distance. So let's define what is a norm vector space before we define this distance. So a normed vector space is a vector space on which a norm is defined. Suppose A is a vector space, then a norm A is a real valued function A which satisfies the following conditions. Zero vector. Zero vector will have zero strength. Scalar vector factor. Direction of the vector doesn't change when you multiply it with a positive number, though its length will be changed. Triangle inequality. If the distance of is the norm, then the calculated distance between 2 points will always be a straight line. So it's a metric. Minkowski distance is a metric in a normed vector space which can be considered as a generalization of both Euclidean and Manhattan. So you can see here sigma xi minus yi to the power p, and then I make a pth root of the same. Finally, Hamming distance, I think you should be familiar with this from information theory. So it's a metric for comparing two binary data strings. While comparing two binary strings of equal length, Hamming distance is a number of bit positions in which two bits are different. How do you calculate? A simple XOR operation will do. Suppose there are two strings 110, 11001 and 100, 11101. Hamming distance will be 1 and 1 similar, 1 and 0 there is 1 dissimilarity, 0 and 0 similar, 1 and 1 similar, 1 and 1 similar, 0 and 1 not similar, 0 and 0, 1 and 1. So 2. Now if you take XOR, you will have two ones. So by taking XOR, you can count total number of ones. That is same as the way we calculate the differences. So this is a small summary of various popular distance algorithms. As I said, there are even more algorithms. I have only taken a few as examples. Now, what is eager learner and lazy learner? We said before, but let me tell you once more. Lazy learning is simply stores training data and waits until a given test tuple. Less time in training but more time in predicting. Accuracy effectively uses a richer hypothesis space since it uses many local linear functions. KNN is a very good example of lazy learning. They only learn when a requirement comes. Like most of us, right? We study a day before exam. Eager learning are the most studious guys in the class. The moment they get a training data set, they construct a model, they are very ready to be tested anytime. Accuracy must commit to a single hypothesis that covers entire instance space. Things like decision tree, naive Bayes, artificial neural networks are all examples of eager learning. Another characteristics of KNN is non-parametric characteristic. So parametric model means we have a finite number of parameters, and linear models such as linear regression and logistic regression and support vector machines are all parametric learners. We will see them in separate videos. In non-parametric models, number of parameters is infinite, or in other words, in non-parametric models, complexity of the model grows with the number of training data. So KNN, decision tree, etc. are all considered non-parametric since number of parameters grows with the size of the training set. Here is a table that summarizes the difference between both of these, the parametric models and non-parametric model. I suggest you to pause the video here, understand the differences, find out the advantages and disadvantages, limitations of both of these type of models before you proceed. Applications and examples of KNN. For example, credit ratings, collecting financial characteristics versus comparing people with similar financial features to a database. By the very nature of credit rating, people who have similar financial details would be given similar credit ratings, isn't it? So therefore, they would like to be able to use the existing database to predict a new user's credit rating without having to perform all the calculations. Or things like, should the bank give a loan to an individual, very similar to credit rating. In political science, classing a potential voter to a will vote or will not vote. More advanced examples, things like handwriting recognition, video recognition, image recognition, the space is infinite. Some pros and cons of KNN. KNN does not make any assumptions, which is very good. A very simple algorithm, very easy to understand, high accuracy, versatile, can be used for both classification and regression. However, it also comes with some cons. Computationally a bit expensive because algorithm stores all the training data. High memory requirement for the same reason. It stores all training data. Prediction stage might be slow because of lazy learning, sensitive to relevant features, and the scale of the data. So in summary, KNN is like, show me your friends, I will tell you who you are. Thank you guys. Bye.